Last video. Yay, you made it. All right, so solving systems of linear and quadratic equations. So we've talked about the number of solutions there can be. We've talked about how to graph these and shown you how to do that. And I've shown you how to solve these now algebraically. So what this last thing is about is this is something you're going to want to use before you go into solving one of these algebraically. And the reason you want to use this is because it can save you a lot of time. And the reason it can save you a lot of time is if you spend 5 minutes substituting in and then moving everything around, getting your quadratic equation, and then maybe you got to use the quadratic formula and you're putting everything together, and then you realize that, wait a minute, I did all this work and this thing has no solution, right? And yeah, you could have figured that out a lot quicker if you did Desmos, but what if you don't have access to something like that? And the only way you can do it is algebraically. So what this allows you to do using the discriminant is it allows us to kind of do like a quick pre-check before we're too far into the problem, and it saves us a little bit of time if we know there's not going to be a solution. So I'm going to show you how that works. So we're going to start these systems of equations the same way as how we've always started in the past. So what I'm going to do is I'm going to take my linear equation, I'm going to solve for y, and in this case it's already done. All right, so y is equal to x plus 1. And I'm going to take that x plus 1 and I'm going to substitute it in for that y. And then that's going to give us x plus 1 is equal to x squared plus 2. Right? So next thing I'm going to do is what we did before, which is let's get the side without the x squared thing. So that would be this side. We're going to get that equal to 0. And then we're going to solve our quadratic because we know we have a quadratic because of that. So we're going to subtract x from both sides, and there's nowhere to subtract it. So I'm going to put it off over there, and then we're going to subtract 1 from both sides as well. So that's going to get rid of everything here and give me 0 over here. It's equal to x squared. I'm going to move this minus x right next to it. And then 2 minus 1 gives me 1. And we have a quadratic that looks like I cannot factor it. So what I want to do now is I want to see, okay, is there some kind of solution for this? And if so, how do I find it? And you should, you could try completing the square, but that's going to give you some really ugly answers and everything. So let's try doing the quadratic formula, except instead of doing the whole quadratic formula, we know that if we can figure out b squared minus 4ac, which is the discriminant, that's the amount that's under that square root sign, right? So we know that if this is equal to 0, then we have one solution, and I know there's a solution. I know that if b squared minus 4ac is let's go back, is greater than 0, then I'm going to have two solutions, right? And I also know that if b squared minus 4ac is less than 0, I'm going to have no solutions. So you're not exactly hoping for this last case, but I want to see if it is that last case, because if it is, then I'm going to give up on this. I'm not going to do any more work. I'm just going to say no solution and be done with it. So let's check that out. All right. So in this one, you have a coefficient of 1 here and a coefficient of 1 here. So all your coefficients are basically 1 or negative 1. So b squared is going to be negative 1 squared minus 4 times a is 1 and c is 1. Right? And then that's going to, negative 1 squared is just 1. And it's 1. And then 4 times 1 times 1 is 4. And you have 1 minus 4, which gives you negative 3. Aren't you glad we checked this first? All right. And so if this is negative 3, that means we have a situation where there is no solution to this. So you would just say no solution, or technically the correct answer is there's no real number solution to this. All right. So there's no real number solution, to this. And we were able to find that out without having to, bust open the whole quadratic formula and save ourselves, quite a bit of time. So let's look at another case for this. And then again, I'm not asking you to solve these. I'm just asking you to try to look at these. So let's start with our linear equation. All right, and we're going to do this part up here, and I want you to solve for y. So I'm just going to write this down again. So we have this, and to solve for y, I would just add 3 to both sides, and then you get y is equal to x plus 3. So we're going to take this x plus 3 here, and we're going to substitute it in there. So that's going to give me x plus 3 is equal to negative x squared plus x minus 1. Now, I have an x over here, and I have a positive x over here. I have the same thing. So those are going to cancel with each other, right? Because if I subtract it from one side, it gets rid of it from over there. That gives me the 3 over here. I want to make this whole left side equal to 0, so let's subtract 3 from both sides, all right? That gives me 0, and I get negative x squared minus 4, okay? So we've got, that means our a is equal to negative 1, our b is equal to 0 because it's not there, and then our c is equal to negative 4. And so let's check our discriminant and see if there's a solution for this. So that's b squared minus 4ac is our discriminant. So b is 0, so we have 0 squared minus 4, a is negative 1, and c is negative 4. So we're going to have 0 minus, well, 4 times 4 is 16, times 1 is 16. You have a negative times a negative times a negative, so the whole thing is negative. So it's 0 minus 16, which gives you negative 16. And again, you can't have a negative number under a square root at this point with what we know. So the answer to this one is going to be no real number solution. All right, and that's how the discriminant can make your life a lot easier. So this little skill was brought to you by Algebra, and I hope you use it when you're doing your ALEKS problems.